Alright, so I'm going to show you how to solve some of these calculations for this impulse momentum theorem. And if you remember, we have a couple equations for momentum. Let me get rid of this P up here. Okay. And the first one's pretty easy. It's just P equals mv. And the P is the momentum, and then the m is mass, and then we times that by the velocity. So momentum is just talking about what's the thing weighing, how fast is it going, and momentum is just a product because we have multiplication. And that's a pretty easy one. You just plug in mass and velocity, and it tells you the momentum, or you can, if you know the momentum and the mass, you can figure out the velocity of it. Then the other one is a little bit harder. And I'm going to change the color here. This one is the impulse momentum theorem. So let's draw that area down here. And it has some different units. Ft equals change in P. And this you probably know. This is the change in momentum. So I'll add that. These are a little different though. This is force, and then this is time. So for this equation, and this would be a product in here, if we take force times time, we can figure out how much the momentum has changed. And force is kind of easy. You just get a unit of force. And time is kind of easy. But what does all this mean, the change in momentum? Well, change in momentum is, how much something initially has in momentum and how much it's now changed from that original. And this is kind of similar to the acceleration equation we used. And we're going to kind of take this equation here with its P equals mv, and we're going to plug it into this part right here. Here's how we do that. So we're going to leave this part. We know what this is. Force times time equals the change in momentum. And what we do is we compare momentum final, P final, minus, we take away momentum initial, and that tells us the change, right? We had a certain amount initially, and now we have a new amount, and if we subtract one from the other, we know this change, okay? But still, P is just momentum, it doesn't really tell us that much. But then we can take this mv and plug it in. So let's go to that next step. So for momentum final, it's also equal to mass velocity final minus mass velocity initial. So that's really where this equation ends up to be useful. If it's just this change in momentum at Ft, it's not really that useful. It's when we get it down to the core of it, and it's mass velocity, final and initial, then it becomes useful. So I'm now going to show you how you use this equation once you kind of understand where it's coming from. So let's go to the first example type problem. Okay, so this one says, calculate the impulse when a force of 80 newtons is applied for 5 seconds. So this is really the equation we're going to use. I'm just going to leave it in the change in momentum for this one, because really what we want to do is the impulse is the change in momentum. And it gives us a force of 80, and it's applied for 5 seconds. So if we just go 80 times 5, that gives us the change in momentum, or the impulse. And then we know 5 times 80, 400, is equal to the change in momentum. Now the unit for this is kind of a weird one, because it's really just force times time. So force is newtons, and we put as times s. So 400 ns is the unit for the impulse. So these are kind of easy ones. You just take force times time. It's kind of like the P equals mv, but we just see what we have. Here's the force, right? Force of 80 newtons, plug it in for that one. And then we have the time. Plug it in for that one, it'll tell us what this is. So that's the first example. These ones are pretty easy. The next two are a little bit harder. So if we look at them, so this one gives us a lot more information. This one says, if a vehicle with a mass of 1,250 kilograms starts at a speed of 25 meters per second and slows to a speed of 10 meters per second in 4 seconds, what force was applied to the vehicle? It's a lot of stuff going on there. But whenever you see something like this, you know you have a mass, you know you have starts at a speed, so we know we have a velocity initial, and we also have slows to a speed, we know we have velocity final, and the mass, right, and then we have a time, 4 seconds. So we got what force? We also have that, but we don't know what that is. So we have force, we have time, we have velocity final, and a velocity initial. So for these, we're going to use this equation, Ft equals mass, velocity final, minus mass, velocity initial. And you just plug in what you have. So we want to solve for this force, right? The time we have is 4 seconds, so 4F times 4. And then the mass we have is 1,250. And that's always going to be the same. Velocity final, so slows to, that's 10. And we're going to minus, same thing, mass is 1,250. And then velocity is 25. And then we can solve this. F times 4 equals, let's do these. Let me grab a calculator. So if we do this, we get 1,250 plus 10, that gives us 12,500. Minus 1,250 times 25, that gives us 31,250. And then we subtract them. So F times 4 plus 12,500 minus 31,250. That's going to give us negative 18,750. Still we have this 4, so we have 4 times, or F times 4 equals that. We have to get rid of this 4. We just divide both sides by 4, and that will give us the force. So 18,750 divided by 4, this is 4,000, so we get negative 688, because we're going to round that 7.5 up to 8. This is going to be newtons, that's the force, and that's how you figure those out. Okay? So don't worry about the negative, because it's just saying it's an opposite force, it's against the motion of the vehicle, and that's how you solve them. So you just go, start off with this equation. This one's going to give us mass and velocity instead of that change times speed. We plug each one in, and the mass is always going to be the same. You see that the vehicle mass doesn't change, and then we just plug in each of the velocity final, velocity initial. Do the math. We're going to sometimes get a negative answer if it's slowing down, and divide by the time, and we'll get force. The other way to do these is for time, and it's really not that much different. We go and look what we have. It says how long. That's going to be time, right? How long. For a vehicle, here's our mass, 1,300. Traveling at a speed, so this is your traveling, it's velocity initial. To slow down to, there's a slowing down, this is going to be velocity final, and then here's a force, 3,000 newtons, that's your force. So then we use our equation, Ft equals mv final minus mass, velocity initial. Plug everything in, we know we have 3,000 newtons times time, and then we have a mass of 1,300, and velocity initial is 15, and we're going to do the same thing on this side. 1,300 is the mass, and then it's going to be velocity initial is 15. Okay? And then we're going to just do 3000 T equals 1300 times 15. That's going to give us 1300. That's not right. Do it again. 1300 times 15. It's going to give us 19,500. And that's going to be minus. Wait, that's 5. I got that wrong. So I go back. I made a mistake here. This is 5, not 15. This slows down to 5, so we go back. Made a mistake there. We go erase this. Just notice this as I was working through it. Okay, so this should be 5. We're going to change this one. Okay. And then if we do this, so we go back to this is 5 now. So 1300 times 5. 6,500. And then this one's going to be the 19,500, but I'll check it. 19,500. We're going to do the math. This could still remain this. So 3,000 T equals 6,500 minus 19,500. Gives us negative 13,000. And then we're going to divide by 3. You get T by itself. And that's going to tell us the time. This will give us T. .3 seconds. That's kind of how you do that. Sorry about that mistake there. The velocity final is 5. I had 15. But again, that's just how you use the equation. It's Ft equals mass velocity final minus mass velocity initial, or it's force times time. Let me just plug everything in, go through the calculations, and you'll get whatever the time is. So let me know if you still need some help on this, figuring these out, and answer the few questions at the end.